Welcome back. We are still doing linear equations. We are up to part 1b. So we are here. Our objective for today is to construct linear equations. And this is 1b. Our success criteria is to be able to successfully create equations from words, then solve the created linear equations using algebra. So you'll be given worded problems. From the words you have to deduce and come up with the equation and then solve them. Let's have a look at some examples. Alright, now before we start, just be careful that you need to give the unknown a letter or a name and stick to it, and you have to be using same units. So one of the tricks that is used is they might give you part of the data in kilometers and the others in meters and centimeters. So you have to be consistent and change all of them to the same unit. Also, when you are doing your calculations, you have to make sure that at the end you answer the question. So after you have calculated what the value is, look back at what the question is asking you and put it in words. So if they're asking you about, let's say, the distance, so after you calculate, say, and the distance is blah blah blah. Alright, let's look at the first example here. This example 7, let's zoom, yep. So a chef uses the following rule for cooking a turkey. Allow 30 minutes for each kilogram weight of turkey and then add an extra 15 minutes. So let's say you had 5 kilograms, so you multiply by 30 minutes and you add to it 15. 5 times 30 is 150 plus 15, 165 minutes. That's if you're working in minutes. If you work in hours, 30 minutes is half an hour. Now let's continue and see what they give us. If the chef forgot to weigh a turkey before cooking, but knew that he had taken 3 hours to cook, calculate how much it weighed. See here, there they're talking minutes and here they're talking hours. Okay, so we need to change either all of them to minutes or all of them to hours. If we stick to minutes, then let's write it here. Okay, 30 minutes per kilogram. And if we call the kilogram weight X, let that be called X. So 30 times X plus 15 is our total cooking time. Alright, so that's denoted as C. So cooking a turkey, let's call it C. So it takes C. So we say equals the cooking time. Alright, so this is the actual formula for cooking. So if you know how many kilograms you've got, you will have the total time. And vice versa. If we know the total time, we will get how many kilograms, because we are saying that it is abiding by this rule. So if the chef forgot, but he knew that it took 3 hours. Now the 3 hours here, 3 times 60 equals 180 minutes. So let's use this. So we don't know how many kilograms we've got. 30x plus 15 equals 180. This is what we need to find out, the x. So like usual, we take the 15 to the other side. So 180 less 15, which is 165. Okay, then x would be equals to 165 divided by 30, which is 5.5. Now, we also need to include the unit. So 5.5 kilograms. And then we state that the turkey weighed 5.5 kilograms. So that's the final thing, is to write it. The question is how much it weighed. So we say, yeah, the turkey (5.5 kilograms). Okay, so very important. Find the rule, find the extra information they gave you, utilize the rule, get the value, and then answer the question. Okay, let's move to the next example. Example A. Find the area of rectangle whose perimeter is 1.08 meter if it is 8 centimeter long. So you see that I'm mixing meters and centimeters. Okay, we start with 1.08 to multiply by 100. This is 108 centimeters. This is the first step. 108 centimeters, this is perimeter, and its length is 8 centimeters longer than its width. So let L length and W equal width. Now I'll solve it in a slightly different way than what this shown there. You can do it either way, it's the same. I'll do it in the more natural way, more logic way. So we know that the perimeter equals 2 length plus 2 width. Now they are telling you that the length is the width plus 8. So it's 8 centimeters longer than the width. This is the relationship. So if we substitute the values here, perimeter they gave it to us is 108, okay, equals 2 times, we substitute the length with its value, W plus 8 plus 2W. This way, we actually change to having only one unknown. So we're using the values they given us and the relationships. So that gives us that 108 equals 2W plus 16 plus 2W, which is 4W plus 16, which means if we change it to the other way around, 4W plus 16 equals 108. Therefore, 4W equals 108 less 16, which is 92. And then we will end up with W equals 92 divided by 4. Okay, which is 23. So the width, and it is in centimeter, 23 centimeters. Now, if we call that equation 1, then we substitute, we say 1 gives us that the length equals 23 plus 8, which is 31 centimeters. So we found that the length is 31 centimeters and the width is 23 centimeters. So we just tried them like there. It's the same as what they found. So we write the length 31 centimeters and the width is 23 centimeters. Okay, now the other way is If the length is 8 centimeters more than the width, then the width is 8 centimeters less than the length. And that's what they used here. So the width is the length less 8 centimeters. And instead of substituting L with its value, they substituted the width with its value. So they got the terms with only L as the variable. They got L, the length, and from the length, they got the width. Okay? So it's both of them are equivalent. But one, the way I've done it, it goes more like what they told you. The other one is, yes, from what they told you, you get the equivalent of it. So you're saying, it's like saying you are 8 years older than your sister, then you can say your sister is 8 years younger than you. So I use the term like they said, you're 8 years older than your sister, while they used, so your sister is 8 years younger than you. So both ways are equivalent and they are the same, and as you see, they give you the same results. So we got the length 31 centimeters and the width 23 centimeters, and that's what they got as well. Now, we haven't finished yet. If you stop here, then you have not completed what's required. What they're asking you right from the start is find the area. So if you go and check, because you want to write the answer, it says find the area. The area of rectangle is length times width. So now that you found that the length and width are these, you just multiply them, and then you get this. So the area is 31 times 23 equals 713 centimeters squared, because centimeter times centimeter is centimeter squared. You'll study later on exponentials and indices. So don't forget to put the units and to go and check that you have answered everything they asked from you. Moving on. Last example. Adam normally takes 5 hours to travel between Hyatt and Logat, 2 suburbs. One way he increases his speed by 4 kilometers per hour. To find the journey from Hyatt to Logat, he finds that it takes half an hour less than the normal time. Okay, now don't forget that speed is kilometer. So if we write it, speed, let's write it there. Speed is in kilometers per hour. So distance over time. So distance equals speed multiplied by time. Okay, so the input, they are telling us the total time is 5 hours, and we don't know the speed. So, but they are saying that what's common is the distance. Okay, from the first equation, distance equals the time times the speed. Okay, now the second time when he changed his speed, it's the same distance again, equals, it took half an hour less, so 5 minus half an hour is 4.5 or 9 over 2, multiply by the new speed. So if you call that one S1, this is S2, the new speed. So what's happening is that's the first speed and that's the second speed. What's the relationship between S1 and S2? Well, S2 is S1 plus 4. So it's 4 kilometer quicker, increased the speed by 4 kilometer. So if we are to substitute it, so if this is equation 1, this is equation 2, and let's call that equation 3. So 3 into 2, so substitute 3 into 2, we get that the distance equals 4.5 times S1 plus 4. And let's call this equation 4. Okay, so now we've got, since D is the same distance, so 1 and 4 gives us that 5S1 equals 4.5 times S1 plus 4. So S1 is the normal speed required to be found. So rearranging, we get 5S1 plus expand equals 4.5 S1 plus 4 times 4.5. So we bring that to the same side. 5 S1 minus 4.5 S1 is 0.5 S1 equals 18, which means this is half S1 equal 18, therefore S1 equals 36 kilometers per hour. So his normal speed was 36 kilometers per hour. So that's what we did. Let's recap. So first we started by writing the equation, distance equals speed times time. So we call the normal speed S1, we have the time S5, so the distance is 5 times S1. From the second one, we get the distance equals the new time it took times the new speed, called S2. So now I've got two equations, and from here, we know the ratio between S1 and S2 is that it's 4 kilometers more. So S2 is S1 plus 4. And then we substitute to get just one variable, which is S1. So we put S2, and we change S2 into its equivalent value with S1. D equal D, so we put them as equality, and we solve for S1, and we get it. And if we wanted S2, then we just need to add 4 to it, so it will be 40 kilometers. So the first day he went 36 kilometers per hour, second day 40 kilometers per hour. Now, the pitfall in this one is by. If you didn't treat carefully and you substituted to 2, then the whole equations will change. Because then, instead of S2 equal S1 plus 4, it becomes S2 equals 4. And then it will be totally different equations and totally different results. Okay, so be very careful how to read and while you're reading. So it increased by, so it is increased by 4, so we added to the 4. If we said increased to 4, so it was whatever it was, now it is 4. It will be totally different. So they didn't say to, they said by. Okay, so that brings us to the end of this section 1B. Let's recap. So the steps for solving a word problem with a linear equation or linear equations. Read the question carefully and write down the known information clearly. Identify the unknown quantity that is to be found. Assign a variable to this quantity, whether you call it x or otherwise. Form an expression in terms of x or any whatever variable name you have used, and use the other relevant information to form the equation. Once you have that equation, solve it, and the final step is write a sentence answering the initial question. So revise the initial question, make sure that you found everything that's required, and write it as a sentence with the answer. Now, for homework and practice, with this chapter, knowing that many people have problems with word problems, I suggest that you actually try all of them. And as we go, I'll actually be giving you a solution to some of them. And I suggest that you have a go at the last few. Okay, so let's say from 10 to 14. Normally the questions are harder as you go, starting from simple to harder. So test your knowledge. They give you hints by saying, next to it that this is similar to example 7, this is similar to example 8. So you can go back and check and find the similarities and see if you can solve it or not. And then attempt the harder questions. And if you have any problems, by all means, approach me. But I would like to see your attempt. Don't just tell me I don't know how to do it. I want to see your attempt in order to find out where you had problems. So that's it for today. Now for the next session, we'll be introducing simultaneous equations 1C. So till we meet again, I bid you farewell.